So we're going to talk about scientific method. And what we're going to do is talk about what our roles are as statisticians in the process of conducting research and science. So let's grab a cup of coffee and see if we can make sure you feel comfortable with everything that's going to be happening. So usually how this begins is that a researcher will review literature and wrap their head around all of the information that that's being published and kind of synthesize all that information. Let's say that a researcher has read that a lot of articles are saying the more coffee students drink, the better they understand material they're trying to learn. Once they understand that, usually what happens is the researcher will develop their own hypothesis. Maybe there's something about the literature that hasn't been addressed, and they're wondering if that could be the true source of what's going on. Let's say, for example, all the research we've read so far is about warm cups of coffee being consumed and how that relates to test performance versus no coffee or nothing to drink. Maybe the researcher will think, maybe it's not the caffeine in the coffee as everybody's been proposing, but maybe it's just drinking something warm and friendly allows students to do better on a test. So then they must formulate a testable hypothesis about this idea of drinking something warm so that they can move forward with testing that. There's a key element here, though, going into this step, which is it has to be a testable hypothesis. You can't make it something that you can't falsify. It has to be something that a researcher can actually prove right or wrong. So for example, if I wanted to know if it's the warm cup of coffee versus, a warm drink versus coffee, then perhaps I will say in my hypothesis that drinking something cold will have no benefit, whereas drinking something hot will have a benefit. So you want to make a hypothesis that can be tested and not just still leave you with questions. So our hypotheses are going to be formulated in a yes, it worked, no, it didn't work kind of technique. It's not going to be how does coffee affect your test performance. We want it to be something specific that we can address. Once we've come up with a design, then you would, a hypothesis, then we would develop a study design and collect the data. These two steps are really the most difficult steps that there are in conducting research. I think a lot of students think that the statistics is the most difficult step, but actually that's very prescriptive. The hardest part is coming up with a hypothesis that's testable, that has a clean idea behind it, and then designing a study that without flaw to assess that. Before I move on to the next step, I do want to address the fact that we have to make sure that our hypotheses are falsifiable. And what that means is that you have to just put something forward that you can actually prove wrong. A really important or significant example of a non-falsifiable hypothesis is there is a God. No matter what evidence we see, it can be explained away as proving that there is a God or there isn't a God. It all just depends on your spin. And so that's a hypothesis that we'll never be able to scientifically assess. There's just no way to answer the question, is there a God or are there gods? There's just nothing we can do. All the data that come out of any kind of question that we would assess can be spun based on whatever you want to say, or whatever you're looking for. So we want to make sure the hypothesis is testable. Here's a funny example just to help you see it. Let's say that I think there are invisible aliens on Mars that if you come near them, they will subconsciously influence what you want to eat. Now, that's not a very testable hypothesis. We could have to go to Mars, we'd have to find invisible aliens, and then we'd have to assess somehow that they're subconsciously influencing what we want to eat. That is not a clean, testable hypothesis. We want to make it something that we can clearly assess and then prove wrong or prove right. So think about that as you're moving forward. All the studies that we present in this particular class are going to be testable, falsifiable hypotheses. But the whole inner workings of how to do that, that's really addressed in a class we called research methods. So these last two steps are really so difficult that we can dedicate a whole class to them and a whole field. So you will want to make sure that you feel comfortable doing that. Let's assume that those have been done right and the study design was done right and we've collected good data. Then the next step is for us to analyze the data, and that's what we're going to do in this class. So as statisticians, we're going to take all the data and make sense of it, see what they said about the hypotheses, and we're going to learn how to do this piece in this class. Now, after you've analyzed the data, then usually the next step for a researcher would be to write up their results and then submit a manuscript to an editor and see if the editor wants to include it in their journal. Now, all journals have the right to say no because they didn't think it was interesting, but there are a few things that I think are important to note at this level of the process and scientific method. The first is journal editors will only publish research that finds a significant difference between your groups. So I'm going to pause and see if I can help you wrap your head around what that means. So let's say that we did do the coffee drinking thing, and we found that those who drank a hot coffee and those who drank a cold coffee had the same level of performance on a test. So you might think, oh, we should publish that and then show that it's not really about the warm drink versus the cold drink thing. Maybe it's back to the idea of it being caffeine. Well, because we didn't find a difference between the cold coffee and the hot coffee, we won't be able to publish that study. And I think that's really important to note. Now, it might feel like that's maybe a bias, especially if you're trying to look at something like, let's say, intelligence, and you want to see if men and women have the same level of intelligence. And let's say your research shows that men and women are equally intelligent. Don't you think we should publish that and share that with everyone? But that won't be published. It would only be published if we found that men and women had different intelligences. So that feels weird. And I'm going to ask that you hold that thought. I need to lecture more throughout the semester to teach you why that is. Some of it's legit, some of it isn't. Most of it is a justifiable reason why editors have this bias. But I want you to consume that and think about that when you're looking for research. So if you don't go on and conduct statistics in your future, please understand that the research that you're consuming is research that has found a significant difference between groups. So, for example, when my daughter was little, I was trying to find if there was anything saying that would be better for her to go to a daycare versus spend time with my mother-in-law when I had to teach a class. And I couldn't find any literature on, children being different between those in daycare and those spending time with a parent or a mother-in-law. Now, I venture to guess that there are researchers who were interested in that question as well. I can't be the only one who wondered that. But the fact that I didn't find anything to me suggests they were probably seeing there's no differences in those kids, and therefore they weren't getting published. So when something matters to you, if you're trying to see, does using my cell phone, does that put me at an increased risk for brain cancer? I can guarantee you there are other people with that question. But if you're not finding any research that suggests that there's something happening there, that may be because people who use their cell phone and people who don't use their cell phone may not be different in their brain cancer rates. And so that's an important thing I want to emphasize here. There's a second piece that's unique to the field of social sciences that I need to discuss here too. So there's a drop-off of manuscripts that don't get published because they don't find a difference between groups, but there's also a drop-off of manuscripts of research that's done just to purely replicate a previous study. So in the field of social sciences, if someone conducts a study, let's say that they've done the coffee intelligence one, and you want to test and see if, wow, that seems hard to believe. Let me see if I can find the same thing in my lab. You won't get published. Or maybe you might get published, but it's really unlikely. The field is trying to move to being more about replication. But for the longest time, if you purely just replicated another person's study to see if you could believe what they found, you wouldn't get published. And that's a bad thing, because we really should be checking each other and making sure that these weren't just random flukes that happened. The fields of biology, chemistry, physics, they actually do publish replications. And you do find that sometimes they don't replicate each other, and then it starts a whole discourse about why some studies found one thing and others who were trying to do the exact same thing found a different result. And so it's a downside of the social sciences that we just trust studies as they've been published and we don't really try to reassess them. So I'm going to be sharing some articles with a new movement of people trying to encourage replications, but I just wanted you to understand that as well, that there are studies being done, but not all of them are being published, and I wanted you to know why. So then ideally what happens is you find a difference and it's a new finding, so you submit your manuscript and the editor says, let's send it to 3 reviewers or 4 reviewers, and they all liked it too. Then it would be published, then other people would read your literature, and then they might formulate their own hypotheses that a twist on the study that you did, and this is kind of the process of scientific method. So I want to talk about 2 different designs that are really relevant for us in statistics. There are many experimental designs, there are many study designs, but if you want to learn the inner workings of those, I do encourage you to take a research methods class. But I want to just take a moment to talk about experiments versus non-experiments. So experiments are where the researchers really try to control the environment and only let one thing vary. That would be the independent variable. That's the variable that they think would influence the other thing. So in the idea of the coffee influencing your test scores, I want to control everything. Everybody gets the same test score. Everybody's in the same classroom. Everybody has the same kind of test. The only thing that varies is whether they're drinking a hot cup of coffee or a cold cup of coffee. And so then if I see that those who drank the hot cup of coffee do better, then I can now know it was due to the hot versus cold because I didn't let a lot of other things impact. So the A students were in both the hot cup of coffee and the cold cup of coffee. So an A student getting an A isn't going to be the reason why I find that the coffee differences matter. If I've controlled everything and I've only varied cup of coffee by randomly assigning it to condition, I now know cause and effect. So I breezed past this idea of random assignment. Let me take a step back. Let's say I let you pick what cup of coffee group you want to be in. So I come in and say, hey, do you want a hot cup or a cold cup? Let's say that all A students like hot cups of coffee and D students like cold cups of coffee. And I'm just making that up. So if you like cold cup of coffee, I'm not saying anything about you. I love cold coffee. So if you randomly if you let them pick which cup of coffee they want to have, then it may not be the cup of coffee that's dictating their score. It may be that A students tend to pick hot cups of coffee, and so A students were going to get A's anyway. So the cup of coffee is not really a causal factor in the outcome, but it's more of an indicator of what kind of student we're looking at. So instead, we want to randomly assign them to conditions. So I flip a coin or I do something random. I pick what condition they're in. So I'm going to have A students, B students, and C students, and D students all in the hot cup. And then I'm going to have A students, B students, C students, D students all in the cold cup of coffee. And therefore, it's not really the kind of student that's in the condition that matters. It's what condition they are in that matters. If I've done all of those things right, I've controlled everything, and I've randomly assigned them to condition. That's the really key piece behind the experiment, is that you randomly assign them to condition. Then we know what caused the outcome. So we know cause and effect. That's gold. We love to try to make guesses as to what's affecting the behavior. So if we've controlled everything, we can start to get at the cause. That's different from a non-experiment. A non-experiment, we're not randomly assigning people to condition. We might let them pick. Maybe after the test, I just ask people, hey, what kind of drink did you drink before class? So it might just be an observation where I'm not manipulating their world. So non-experiments have a very different kind of approach in terms of interpreting the results. We don't, even though we might want to assume that, oh, it looked like those who drank hot coffee did better, we don't know if it was just hot coffee was consumed by A students, and that's why it looks like it matters. So that's something we want to keep in mind when we're analyzing our data. Was this an experiment or was this a non-experiment? So let's just see if we can practice identifying the difference between an experiment and a non-experiment. Let's say I have a placebo and I want to see how that differs in how long people live versus my drug. I have a new drug that I'm administering. Let's say I randomly assign people to either get the placebo or a drug, and I look at how long they live. Does that sound like an experiment or a non-experiment? So hopefully you're thinking experiment, and the key piece there was that I randomly assigned them to placebo versus drug. And so if you've ever taken a class where you've discussed placebo, you know you can't just tell someone you're getting a placebo, because the placebo effect is based on the idea that you think it's going to work because you're taking a drug. And so if you know it's not really the drug, it's not going to have the same effect. Or let's try another one. Let's say I want to know if cell phone use leads to increased risk of brain cancer. Let me just leave it at that. Let's say the study looked at cell phone use and the increased risk of brain cancer. Just based on what I said, is it likely that it's an experiment? So what would be required for it to have been an experiment for me to know that cell phone use caused brain cancer? Well, first of all, I'd have to control everything, but I'd also have to randomly assign people to use a cell phone or to not use a cell phone. I just want you to think about the likelihood that someone was able to conduct a study where they told people not to use their cell phone for several years. And then to have other people use it regardless of what they wanted, you have to use a cell phone. That's unlikely to have happened. More likely, if you see a study that says cell phone use is tied to brain cancer, they were probably just recording, asking people, hey, how often do you use your cell phone? And then let me see if you have brain cancer. And then they're not doing an experiment, they're more just observing how things naturally happen. So you want to be looking for keywords in the design if they're randomly assigning people or not. Well, let's say that the study title is students who take notes with paper and pencil did better in the class than those who took notes with a computer. So now you have to think, does that sound like an experiment or not? And actually this one could go either way. That title didn't really describe. Now if they said exam scores were recorded and then students had to indicate whether they take notes with paper and pencil or with computer. The way I just described it is not an experiment. They recorded the exam scores and then they asked students to just tell us whether they took whether they take notes with paper and pencil or a computer. That isn't randomly assigning them. That's just letting it be as it naturally was. So that's not an experiment. But if I had said, oh, half the students were assigned to use paper and pencil and half the students were assigned to use a computer, and then we looked at their test scores. Well, the way I've described it this way, that sounds like an experiment because I put them into the paper and pencil condition and I didn't let them pick that. So see the subtleties there, deciding whether it's an experiment versus a non-experiment. All right, one more. I want to know if drinking coffee makes people happier. Okay, just like that, might be hard to tell. Now, if you see a study that says, research shows that older Americans feel happier when they've had a cup of coffee, as might be something you hear on the news, I would question whether that was an experiment. Usually experiments are harder to do. So for it to be an experiment where I know coffee caused them to be happier, I would have to know that they randomly assigned some people to consume coffee and some people not to consume coffee. Well, it's unlikely, it's hard to get adults to commit to not drinking coffee if they're coffee lovers, and it's hard to get people to drink coffee if they don't want to. So more than likely, if you see a study with that kind of a title, it is that they just looked at people, asked them how much cup of coffee or how much coffee they drink and how happy they are, which means we don't know what really caused them to be happy. Maybe it is that happy people tend to like warm drinks or tend to like caffeine. We don't know what the cause was. So what we can see is that it really comes down to, did they randomly assign people to condition? That is one of the hallmark features of an experiment that lends us to making the cause and effect argument. So if it's missing that piece, it's not an experiment. All right, just a little bit more. So we want to talk about the different kinds of variables that we have in our study. So we have the independent variable, and this is the variable that if we're doing an experiment that we have manipulated. So the investigator might manipulate whether you get coffee, the hot coffee or cold coffee. So this is the variable that I think, if I'm doing an experiment, would be the cause of you getting a better or lower test score. So the independent variable is the one controlled by the researcher. The dependent variable, on the other hand, that's the variable we label for the outcome. So this is the thing that we're trying to see how it's influenced. It depends on what you've done to them. So your exam score depends on whether you're in the hot coffee condition or the cold coffee condition. So sometimes we'll call this the outcome variable or the effect. So we often will use these words to just quickly describe a study where we don't have to describe the entire design. I can just say the independent variable was coffee, cold or hot, and the dependent variable was test score. So instantaneously you will know which one I think I'm controlling and which one is the outcome. So we'll try to do some practice with that. Let's say I was doing a study to see if rate my professor ratings change whether professor wears high heels or flats. So thinking about that one, which one is the outcome? So we want to see how rate my professor ratings change, whether the professor's wearing high heels or flats. So what's the outcome of my study? The outcome would be rate my professor ratings. So is that the independent variable or the dependent variable? And the rate my professor ratings would be the dependent variable, which means the independent variable would be shoes, whether you have high heels or flats. So the independent variable is shoe type, and it'd be high heels versus flats. And the dependent variable would be rate my professor ratings. Let's try another one. Let's say we want to know if how many hours, whether you bought the book or not predicts your letter grade in the class. So we want to know whether you bought the book or not, if that predicts your letter grade in the class, which is the thing that is the independent variable. The way I've described it, which is the one that I think is causing the outcome. So this one might trip you up a little bit, because do you think I'm randomly assigning people to buy a book or not buy a book? I would venture to guess that that's a hard study to do. You're probably just going to record whether someone bought the book or didn't buy the book and then recorded their letter grade. However, the way we have worded this, we're proposing that the book purchase is the independent variable, the thing that's kind of causing the outcome variable, which is your letter grade. So even though I didn't do an experiment here and I didn't manipulate whether someone bought the book or not, and I'm recording their grade, we still call book purchase independent variable and letter grade out the dependent variable. That's our outcome. So that's something to keep in mind. Let's say we want to know if we give people dogs to walk, if they have better heart functioning versus no dogs to walk. So what is the outcome variable? What is the thing that I think is the resulting outcome? That would be heart functioning. So that's my dependent variable. And then now let's think about what is the independent variable. And that would be the thing I manipulated, which is whether you have a dog to walk or no dog to walk. One more and then we'll wrap this lecture up. Let's say we want to know if smoking impacts how long you live. So we randomly assign half the people to smoke and the other half the people not to smoke. So what is my independent variable? What is the thing I controlled? And that would be smoking. And my outcome variable would be how long you live. Well done. We've just talked about scientific method and the variables, all kind of related to design.